Systems engineering sounds pretty powerful, right? So you might be thinking, why does it need to change? Why the hype around model-based systems engineering? What's the big deal? Well, here's the thing. While traditional systems engineering has done a great job handling complexity for decades, the world is changing fast. Over the past century, the complexity of our systems has increased faster than our ability to manage it. As systems evolve, they get way more complicated, and it has become a pretty big challenge for traditional systems engineering. One of the main drivers of this complexity is the number of engineering disciplines involved. I mean, think about it. A car used to be just a mechanical system. Engine, wheels, maybe a radio if you were lucky, but today, modern cars are like little computers on wheels. They've got electronics, software, and connected technologies. Each discipline has its own set of problems, which means the more tech we add, the harder it is to manage and integrate everything into one smooth-running machine. And guess what? It's only going to get worse. The automotive industry is undergoing a big change in architecture. Initially, vehicles had separate control units for each function, like braking or lighting. Over time, these were grouped into domains, areas like body, powertrain, or infotainment, each with its own controller to handle related tasks. Now we're seeing a shift to centralized and zonal systems, where powerful computers handle multiple functions, and zones manage features by physical areas of the car. This reduces wiring, which saves space and weight. These advancements are crucial to enabling modern features like self-driving and wireless updates, but it increases the number of disciplines involved. Complexity is also driven by the scope of our systems. A great example is the transformation of the city. Think about it. Optimizing resources, managing transportation, easing navigation, all while making sure people have a great place to live. Systems engineers will need to figure it all out. And as cities are slowly reshaping to be human-centric instead of car-centric, car manufacturers will need to figure out how to plug into this giant, interconnected web of systems. And you better believe this trend isn't isolated to cars. It's happening in every industry, from aircrafts to vacuum cleaners, everything gets more integrated. Remember when we talked about stakeholders in the systems engineering crash course? Well, they are still here, and they are more and more demanding. Systems of tomorrow won't just be about functionality, they'll need to meet a whole new set of expectations. And traditional systems engineering is feeling the heat trying to keep up with all this. Systems need to deliver the expected capabilities, but in the simplest way possible. Think user-friendly interfaces, minimal complexity, and being tolerant to failure. It's all about making sure people understand and can easily use the system. Systems must be developed quickly to meet customer demand and market conditions. If they are not out there in time, the opportunity might pass and the system could fail to deliver value. As systems rely more on software, safety becomes crucial. Systems are being used in scenarios where human, environmental, and property safety matters, so resilience and safety need to be built in from the get-go. More complexity means more safety checks are required. More systems are connected, and with that comes vulnerability. As systems get more complex, the need for cybersecurity grows. Threats must be assessed and mitigated throughout the system's lifecycle to ensure it remains secure and resilient to both cyber attacks and unexpected breaches. Systems need to be reliable and predictable. Nobody wants a system that's unstable or surprises them with failures. They also need to be smart, meaning they can handle a changing environment, help human operators, or even self-organize. They must adapt to real-world challenges while still delivering value. Sustainability is mandatory if we want to keep our planet inhabitable. Systems need to be environmentally responsible, minimizing waste and reducing climate change impact. It's about making systems that last while being kind to the planet, and therefore us. Then, maintenance is key. Systems need to be designed for long-term use with easy upgrades and management. They should evolve over time without causing major disruptions or spiraling costs. Scalability is crucial. Systems need to grow and adapt without falling apart. It's about building systems that can handle increased demand without breaking the bank. Lastly, systems must be affordable. They need to provide value while being mindful of the total cost of ownership, from development to maintenance. So we have an increasing complexity with an increasing number of concerns to take over. Let's see how systems engineering proceeds to tackle all that. Right now, everyone relies heavily on documents to store all that important engineering data. They're created at every step of the process: requirements, designs, test plans, you name it. And these documents are crucial because they help different teams communicate and keep everyone on the same page. But as systems grow in complexity, the amount of documentation required just skyrockets. More systems, more disciplines, more documents, simple as that. But here's where the wheels start to fall off. All this documentation can get overwhelming. With so much information to manage, keeping track of everything becomes a full-time job on its own. And if you've ever tried to find the right piece of info, you know how tricky it can be. Maintaining these documents, not so easy either. As the system evolves, the docs get outdated and things start slipping through the cracks. This can lead to confusion, errors, and those dreaded missed connections between different parts of the system. So you're constantly playing catch-up. Alright, let's zoom in on the railway industry to see just how crazy things can get with document-based systems engineering. Take a typical railway vehicle, it has around 100 functions. Now when you start breaking those down into subsystems, you're looking at up to 1,000 different functions. That's a lot to keep track of. And this leads to something like 10,000 functional requirements. How to organize all that? To manage all of these functions and requirements, you've got 8 to 10 systems engineers working overtime to formalize all this data. And what do they use to keep it all straight? 30 to 40 documents. That's right, 40 documents, hundreds of pages each to capture everything. And you know what? This is just for the systems engineering side of things. We haven't even touched the other engineering disciplines yet, like mechanical, electrical, or software. It's just becoming a nightmare. On average, a worker spends 20% of their time just looking for information. Think about that. 1 out of every 5 hours spent hunting down data or digging through endless documents just to find what they need. Imagine how much more you could get done if that time was spent actually engineering. And to make things even more fun, companies like SNCF, the French national railway operator, now require proof of compliance with systems engineering standards like the ISO 15288. Sounds official, right? But proving compliance using a document-based approach is tedious. Imagine having to comb through all those documents, cross-checking everything to prove that you've met all the standards. In the end, you'll end up being an archivist rather than actually doing engineering. So lots of complexity, but we are used to it, right? We have always done it this way. Why change? The complexity of systems has increased exponentially over the past century, but we are still Homo sapiens with the same cognitive abilities as our ancestors. We are not smarter. What's evolved over time is the knowledge we've accumulated and the tools we've developed to manage that knowledge. Now, what do we do when things get complicated? As projects get more complex, we've tried to keep up by adding more people. The idea is that with more people, we can handle the growing complexity. But more people means more interactions, more communication, and you guessed it, more chances for things to go wrong. With a bigger team, there's a higher risk of misalignment. People might have different perspectives, different knowledge, and different priorities. And since everything is stored in documents, that means there's more information loss and miscommunication, which can lead to delays, mistakes, and a whole bunch of inefficiencies. Not exactly the recipe for success. I mean, look at this. So what do we need to tackle all this? To manage complex systems and keep everything aligned across all those teams and stakeholders, we need a more structured, integrated, and proactive approach. One that can help us handle the complexity, improve communication, and help us identify risks early. And this is where model-based systems engineering comes in.